Let's take a look at example 5.1.4 and show how the idea of functions defined by equations, graphs, and tables can all fit together. So those are three ideas that you've just been reading about. Let's take a look here at this function h. Now, the independent variable is t. So if we were to define this function using the Desmos grapher, we would say h depends on t using normal function notation. And then we say that's equal to 1776 minus 16t to the power of 2. Now, the grapher is automatically going to graph this. The issue here is that we can't see it yet. We'll get back to that in a moment, but this example is asking how we can think about functions with their equations. And specifically, it says after 1 second, the height of that particular book is 1,760 feet. This is the calculation you should be able to show and do on any quiz or exam. If you want to check your work, you can use Desmos. If you've defined the function correctly, then you can say, take h and evaluate it at 1, and it's going to give you the output right there as a check of your work. Again, you still might need to show your work. Make sure you read the directions, but this will be a check. If you want to change the value to 2, h of 2 is 1712, and that matches. So this is a really nice way to look at any value. 2.5 seconds, you know the height is here. So that's how you can actually evaluate functions using their equations in Desmos. Now, of course, the graph should match all of that. And we know that in this particular case, when h is 0, when t is 0, the height is 1776. So when t, which is on the horizontal axis, is 0, the y value, the vertical value, which is actually h, not t, but what we think of normally as the y value, is way up at 1,776. And because we're only seeing 10 here, that tells us that we need to zoom out quite a bit. Now, I could zoom out several times to start to see the graph. When I zoom out one time, notice that I can see the left and right sides of the graph. And so rather than continuing to zoom out and making this very, very skinny, I'm going to go back to this view and then use the graph settings button, which looks like a wrench in the upper right-hand corner. And then I'm just going to change the largest value that I think is on the function. So I have a hint that it's close to 1776. So the y value, I'm going to start that at, let's just say 2000. This is just a guess. And then when I look at that graph, I actually have a very good picture of what's going on. Keep in mind, in this particular situation, the domain of the function, the values for t that make sense, are going to be positive values for t. So these negative values don't really make much sense in this context. So one way you could do that is you could click and drag with your mouse or your trackpad until you see the graph look like this, and then maybe change the x value, the t values, so that they only go up to, let's say, 10 instead of out here at 40. So again, I can use the graph settings and say the x value should only go up to about 10. All right, and now I'm getting a slightly better picture. I don't have a lot of wasted white space. If I don't want this left side, right, if I want to think about this function as a graph with the correct and reasonable domain and get rid of this, what I have to do is edit the function's expression. What you'll do here is do this sort of set notation, this squiggle bracket, and you'll say that you only want to see values of t that are greater than or equal to 0. And that's going to give you a more appropriate domain that you can then adjust as you need to. One last thing you'll notice is that you can also use the Desmos grapher to look at the tables. Remember, in this particular section, we're looking at tables, graphs, and equations. We've looked at the equation and how to evaluate it in Desmos. We've looked at the graph, the function as a graph, and how to get a good picture of what that function looks like with appropriate domain. And we can also use tables. So if you want to look at tables and how a table can be linked to this particular function, what you'll want to do is go up here to this gear up sort of at the top of the equation list. And if you click on that once, you will see this icon which says create table. And if you have a function defined, you'll be able to create a table by clicking on that button. So when I click my mouse, there's the table. And it sort of gives some first guesses at values that make sense. You can see here that because we've defined the domain to be values greater than or equal to 0, if I plug in -2 and 1, it tells me the function's not defined there because that's not in the domain, right? If I want to know what's the value at 2.5 seconds, I just put that in on the left side. It's labeled as x, but we have to remember that t is playing the role of x here. But when we do that, 1676 is our number. And now notice on the graph, these points are actually being displayed on the graph and they match what's in the table. So at 2.5, that's the point we just put in. At t equals 3 seconds, it puts in another point at 1632 feet. So we can take these values out if we don't want them, replace them with other values, whatever that might be. But this gives us an idea of how to look at the table and how it interacts with the graph. They should match. Unfortunately, we cannot enter in the dependent variable, typically the y value over here. It only allows us to plug in a independent variable number, the x, or in this case, the t value, and then it computes the corresponding dependent variable value. So there you have it. This is one way to look at all three pieces of how we can work with functions. We have their equations, which we can evaluate using Desmos. We have their graphs, where we can visualize what's happening. And then we have table values, where we can see how different values impact the value of the function.